Welcome to Fragmented, an AI developer podcast that helps vibe coders become software engineers, one episode at a time. I'm your host, Kaushik.
And I'm Iury, the other host of Fragmented, where I'd love to talk about using AI to make you a better developer.
In the last episode, we talked a lot about the agents.md files specifically, but in the grand scheme of things, that's just one piece of the puzzle. You threw this umbrella term called harness engineering. At least that's what the kids are calling it these days. I know you did a lot of research and you have a bunch of articles that you pulled from, and there's some interesting things to talk about. But maybe let's start by giving our listeners a sort of overview of what are the topics we're going to talk about specifically around harness engineering today.
So in this episode, we're going to cover what's harness engineering and why is this even important? So why are people talking about this at all? And how to shape the harness and how to build it. Does that sound good?
Yeah, that sounds good.
I think the first one is very important, right? Why does this matter, right?
Yeah, why even talk about this?
So there was this OpenAI post with this very name, right, called harness engineering, that actually helps explain this really well. I think it's also interesting because they're showcasing something that they did with a real product. It's their code base for Codex that they used as reference for this article. So they have like over 1 million lines of code, and they claim that's zero manually written, like 1,500 PRs merged. So apparently this is the real deal for them. And what it turns out that the hard part was not actually creating the code, but it's basically building the environment that makes the agents reliable to build this code, right?
It was an intentional effort on their end, right? Where they're like, if we were to move in this direction where the agent basically builds the entire product, what are the problems we run into and how do we alleviate and remove those problems for the agent as we go along?
It's a very big shift in the way you do things, right? You actually have to attempt to not manually touch it.
Right.
And then the problems start showing up, and then you have to kind of figure how to solve them. So that's a very interesting case study.
One point that stood out in that post that I thought was interesting was they said explicitly throughout the week, they would basically use agents to generate the PRs, but then they would spend about a good 20% trying to clean up and make sure that they course correct and then add those corrections into the system.
Right. And that's basically what gave birth to this harness engineering thing, right?
Exactly.
It's like the role of the engineer is changing, or that now that we don't really write the code as much, we're more working on this steering part. So we're steering the agents where it's moving.
That's like a mic drop moment, by the way. Just casually.
Like,
yeah, humans don't write code anymore. The agents are. So...
Nonchalant. But yeah, that's pretty much it. The bottleneck now is not if you can write the code, right? But it's like, how can you stop the code from drifting or breaking, because there's a lot more code going in.
Man, this is something we should talk about in a future episode too. How do we even approach the review of all of that code, right?
Oh, that's a big one.
Generating the code is so easy, but how do you actually review it? There's a general theme where everyone is like, yes, at least the human should review the code and make sure slop doesn't go in. But, when you have 1,000 PRs coming your way, no chance you're going to be even doing a good job of reviewing. At that point, It's better to think about how can we get agents to focus? How do we make the agents better at reviewing the code?
Yeah, that's a big can of worms.
Yeah.
Let's go now into what is harness engineering. So I don't know exactly where I got this from, but it's basically this idea of shaping the environment around the agent so that it can act reliably.
Shaping the environment around the agent.
Yeah, if you think about it, like with all the tools and the knobs that they give us. So for example, skills and commands and sub-agents and the context and all the instructions around the agent and the tools that the agent have available. Yeah, so this shifts the focus away from how smart is the model towards like, what tools does it have and how does it get feedback and when does the human steps in?
And this is interesting because there's a different school of thought where, you can think that the models will keep getting better. So you don't need to focus as much. The models will just know how to do it. That's one school of thought. as is the case with most things in AI, right? We don't know where we're going to land end of this year. We might come up with some super GPT-6 or, I don't know, Opus 5, and suddenly the models have become so good and you no longer need to bother about these things. But we never know. At least as it stands today, if you want to get good results, it makes a lot of sense to focus on shaping this environment, like you put it.
I think that's what we try to do in this pod, right? We're trying to be very pragmatic about these tools and the current state because no one actually knows where we're going. So yeah, so this is the whole idea of harness engineering, but I also, I'm not a native speaker, right? So when I first heard the word harness, I was kind of confused. I think I probably first heard it on the context of AI. So I was like, what the hell is a harness? So for the non-native speakers out there, but one of the interesting meanings I found is the one that it's talking about, the straps you put around a horse, for example, when you want to steer it, to control it.
So the model is the horse here, basically.
You're riding this thing, and you need to have the tools around it so you can point it to the right direction, so you can ride it in the right place, right?
Let go of that harness, and you'll fall off that horse, basically.
Exactly. Oh, that's a good one.
Cool. So we mentioned this briefly at the start, Iury, but I think it's important now to split or fork harness engineering into two things. One is shaping the harness, like we talked about. These are the things that you do around the model to help it get better. But there's the other approach too, which is building the harness itself. And this is more like if you wanted to build your own version of Claude Code or Open Code or whatever. So in this episode, what I thought it would make sense to do is split the episode into two parts. The first, we're going to talk about shaping the harness because that feels like the most useful and effective to do now. So we'll spend a majority of our time there. But we'll also touch this concept of building the harness altogether. Okay, let's talk about shaping the harness, which is the first big area to speak here in harness engineering. What does that actually look like in practice? And I think in your newsletter, Iury, which again, we'll add a link to that in the show notes, you pointed towards these 5 areas or themes, so to speak, around shaping the harness. And I liked how you structured those. So maybe we just jump right in and talk about each of those 5 areas.
All right. Yeah. So I've actually read a bunch of different, from different sources, and they were not that structured, but I try to organize them in a way. So this is not any official source or, this is just the way I started thinking about this. So the first big theme, I think, is this idea of agent legibility, which is maybe a weird word. I don't know. No,
I think I understand, but maybe you should explain that agent legibility, which is how do you make it easy for the agent to understand? Can you expound on that? What is agent legibility?
I think behind this is the idea that if knowledge lives in Slack or in someone's head or in some random doc that's linked elsewhere, the agent cannot use it. So for the agent, it essentially doesn't exist. So something that you think it's trivial is just not part of its context, and it's not, discoverable at all.
It's those things, those conversations you have with your product manager or other people in Slack. It's the Google Docs, the PRDs that don't exist in the code base itself. Those are the things you want to sort of capture and encode into this, right? So that feels like the theme here, which is if there are things that the agent has no visibility into, make sure that you encode and put that so that it can start to read this from your code base. Because otherwise it has no knowledge, right? If it can't see it, there's no chance it's going to incorporate that into its reasoning and thinking.
Yeah, it's the idea that the repo has to be more navigable by the agents, so not just for humans.
I like that. Make it more navigable by agents. But the natural question is, how do you do that? What are you suggesting that I do to make it more navigable by the agents?
Right. So going back to the whole agents MD starting point. So now you can have, instead of just having a bunch of instructions like 1,000 lines in the agents MD, you can actually specify that, hey, if you want to understand how the repo works, there is this docs folder where we organize by feature or some kind of theme and some cross-cutting concerns of how the repo works. So you can have some components overview, design rules, coding practices, and all of this becomes more discoverable by the agents themselves.
And just to be clear, like, the docs folder you're saying, so one is actually creating the docs folder, adding all of those things, but then also having that referenced in the agents.md like a map, and that's the important piece.
Yeah, and like nodes can link to other nodes. So when the agent is traversing this documentation, it can figure out by itself, like, well, where does this go and what this is related to.
Maybe we move to the next one. What was the next theme that you brought about?
Yeah, this is something that I think a lot of people have been realizing too, like, and working on, is the idea of closing the feedback loops.
And, closed feedback loop sounds like this control flow theory, some fancy machine learning term. Yeah, but what do we mean by close the feedback loop? Because I hear a lot of people say this, but pragmatically, what do you mean by that?
Well, the agent needs to know when it messed up. So it needs some kind of feedback. So I think the first one could be probably tests. I think they're the baseline. So if you ask it to implement something, it needs to have tests so that when it runs a test and the test fails, you don't need to tell it that it's broken. It can figure it out by itself.
And this makes sense. So this is the idea of even having the tests, right? Because in the last section with agent legibility, you want to also tell the agent how to run the tests. That goes in that section. In this section, now I keep thinking about the term harness, which is a good term. Your code base needs to have the ability to even run these tests in the first place.
Yeah. So for example, one thing that maybe is not immediately obvious is that, okay, if the agent is going to run the test, so the output from the test needs to be clear enough for the agents to act on it. So maybe it's not, if you're depending, I don't know what kind of app you're building or what kind of system you're building, but some tests are not, they're not immediately actionable. You need to inspect the results somewhere. Maybe it dumps the results into a file that the agent doesn't know where it is. So these tests are not useful actually for the feedback loop.
Oh, that's a really good point. So it's not just about writing the tests, it's also how you read the results from the test.
Yeah. It needs to close the actual loop, right? So it needs to...
I see. I like how you did that. So that's the closing of the loop part in this. Okay, that makes a lot of sense. So writing tests is basically the idea of closing the feedback loop. Is there anything else here?
Right. So I think most of the things that we are used as developers, because we need these things as well, right? So if you ever try to write code in a notepad, it's like really hard, right? Because you don't know exactly what's going on. It's just text.
Hey man, 15 years back, Notepad++, I don't know, when I had my C++ courses, we had to do that. Forget Notepad++, we had to write code on paper, as crazy as that sounds.
Way harder.
I know.
That's exactly it. It's way harder. So the agents need them as much as we do.
Oh, I like how you connected that. Okay. That's good. So you're basically saying, remember how hard that was? So don't do that.
Exactly. Yeah, especially for example, even basic things like type checks or linting. And any kind of feedback you can give to the agent will help. So static analysis.
21st century tools, basically.
Right. And then you get to even more higher level stuff, or not higher level, but things that maybe doesn't jump to the eye immediately that you need to build. But for example, the agent needs to have access to the logs. Depending on how your system is built, the logs may be not so trivial to pull from. So you need to get the agent to have that at hand.
I think even in the OpenAI post they mentioned, right? I think they use LogSQL or something. I forget what the tool is specifically that they use there. From first-hand experience, I can also say that, at Instacart, we had to spend some time figuring out how to draw the logs out from our systems in a way that we can feed to agents, because there's so many minor points. For example, your logs could be a ginormous size. You may not even have APIs. You have to paginate your APIs. Or, you set up MCPs, but then the MCPs don't exist for the tools that you use. So all of that is this engineering, right? How do you get to a point where you can get the agent to pull those logs effectively and then use those logs? Because even if you think about logs, there's timestamp. You don't want to pull the logs for the entire day. You want to pull it for that specific moment where it's useful for the agent to pick it up, or the right filters on those logs. So there's a lot of, code engineering that goes into making sure that you pull the information correctly for these agents when they need them.
This is a very good point that you made, like, because I think this is what makes this idea of harness engineering more compelling to me. Because like the previous thing we had was context engineering, right? So context engineering is more in this, like the woo-woo kind of thing that you're just typing words and, trying to find semantic, semantic maps and whatever from the code base, like try to, invoke this good part of the AI. But like here is actual engineering work, right? Okay, no, I need logs. How do I get the logs in? Oh, I need to tie this in. Okay, maybe I have a hook that whenever the model writes code, then I will trigger the linter to format my code base to make sure that it doesn't, that things are very tight. So I think this is closer to the engineering part.
Right. And it applies across the board, right? Say you have screenshot tests, then you need to know how to read screenshots at all, or even set up screenshot tests in the first place. As mobile developers, you need to be able to spin up an emulator or something so that the agent can then actually run the test on an emulator, read the results, whatever it is that you as a human do to check the system.
Yeah.
You need to engineer your system so that the agents can basically do that as well. What's next?
Oh, that's now there comes a complicated one. Lots of opinions out there, and it's most definitely an open problem. But we need to solve memory, some kind of persistent memory.
People approach this so differently. There's so many solutions out there for memory. But maybe you can start off by telling us, what do you mean by persistent memory? And then we can talk about the approaches.
Yeah, so here's the idea that if you don't have a system of record or design decisions and some failure patterns, both humans and agents will keep paying for the same confusion over and over, right? So when something goes wrong, we need to be able to remember that so that doesn't happen again.
We think of memory as preventing past mistakes. What is the difference then between persistent memory and, say, just putting something in your agents.md file?
Because there's basically like two things you can solve with memory. It's like one is this idea of like past decisions, but it's also like basically trying to pick up where you left from.
Oh, that's very interesting. It's not just about if you're starting net new, you want to encode past memory. If you think about how people are approaching memory, and maybe you can talk a little more about this, there's as hacky solutions as I think what Claude is doing, which is there's a memory.md file now, and then you can just use the memory.md file. Then there are people who have tools like, what is it? I think Toby, the Shopify CEO, has this QMD tool, right? Which is feed it across all and, get encoded markdown, and then that you save as embeddings, or I think it puts it in a vector DB, I forget. And then there's, entire systems where you set up an entire indexing process. For those who don't remember, like Cursor in the early days, anytime you open your code base, it would index. There's a range from like a simple markdown to like sophisticated systems.
Yeah, because essentially it's the same thing, right? Because everything's markdown. But I think it's just the way you use it or how you fill that in.
You know how we have RAG, at one point, RAG models were the rage. I have this powerful model, but then I want to layer in some of my learnings. You can put that in a markdown file, like nothing stopped you, but then there are more efficient ways. And because sure, the model eventually might get to the same point and give you the results, but you want to make that process faster. So memory feels like a good way to do that. Because eventually the agent, as these models get really good, the agents will come up with the right answer. You want to hasten that process. You want to get those answers quickly and more efficiently. You don't want to keep burning tokens. It feels like that's the powerful piece of memory.
This is honestly like super interesting topic because you start thinking of like how we remember things and how we surface facts and things.
To your point, maybe we should spend another episode just talking about memory once these solutions mature and people come up with more ideas. So we'll make sure to do that. What's the next one?
Entropy control, right?
This is maybe the one time I'm using my, mechanical engineering background. I feel like, I'm finally using something.
Exactly. Fits pretty well.
It basically means the degree of randomness or disorder. So one of the rules or laws of thermodynamics says that entropy over time will gradually increase. Like, entropy is always increasing. So how do I connect that to my code base?
That's exactly what happens in a code base, right? If you leave it unattended, it just becomes a mess. So
that's a good way to put it, which is, don't do anything and don't expect it to naturally become orderly. By nature, it is going to become disorderly.
Needs a lot of effort to keep things tidy, right? It's just like your bedroom. I had a roommate at some point that he used to say that no matter what, the room drifts to chaos.
Great roommate.
So I think that the thing with agent-generated code now is that this is multiplied a lot because there's a lot more moving things in the code base. There's just a lot more code being written. So the chances of entropy taking over just increase a lot. So
that's a good point because there's so much going in. Yeah.
So the patterns drift, like even if you have like the whole harness engineering going on and you have a bunch of guardrails and you're reviewing very diligently, it's still going to drift and docs will go stale and helper functions might start multiplying. So just kind of like we have with humans, right? Because I think a lot of people now kind of act like humans wrote perfect code before AI.
Right. This is true. It's like, oh my God, all the AI slop code you wrote was not any better.
I've seen a lot of atrocities from humans as well.
So true.
Right? We need to try to control this drift. And I think the entropy control is basically that. So how do you do that in a harness? You can solve it manually. You can try to automate things. You can use more AI to try to control it. That's another thing that people are exploring. For example, you could have an agent for catering to documentation drift, trying to make sure that the docs are not stale. You can do all sorts of things, and this is also like it could be also an episode, I guess. But yeah, you'd have to do something about this.
And with that, we basically come to the last one, I think, that you added here, which is blast radius control. Can you explain what you mean by this section specifically?
Yeah, so this one is just about scope permissions and risk-aware checks and approval gates and everything that you can use to explicitly control what the agent can do, especially in sensitive areas of the code base, right?
I see. So this is the idea that you set up the right permission so you don't let the agent basically suddenly go and RF your entire database, right? I know. I'm sure people have seen the stories, but that's what this theme is about. The blast radius is make sure you don't let your agent actually do the bad things, like or go nuclear on your code base.
Exactly. It's like I heard this before as well. Like when you hear a story that a junior developer nuked the company's database, it's not the junior developer's fault, right? It's like the person that gave him access to the database.
You should have bulletproof systems that don't allow you to even do the wrong thing.
Exactly. Yeah. If your agent is doing something catastrophic, it's not the agent's fault, actually. So you have to do something about that. For example, I had this thing, like very stupid example, but I was trying this Gmail MCP the other day, like some time ago, actually.
Oh, boy.
And that's automated email drafting.
Oh, no.
Right?
I can see where the story is
going. And
it
really had this draft feature. I said, okay, let me use the draft feature. And I think I told it we were going to draft an email and we're just, back and forth over the email. But I think the thing just went on for some time. I don't know. And then at some point I said, okay, let's just do this change and I think we're good. And then it did the change and it sent the email. I was like, what?
Oh. I mean, you didn't say we're good, so.
Right? Okay, so then I learned, though I have to actually not let it send the email, like in the permissions part.
Oh, but that's a great point there. So in the context of harness engineering and this controlling the blast radius, what you would then do in this specific example is go and maybe either add an instruction or basically limit the permission so that you never allow the agent to send something. It can only make draft. You would only give it access to the draft permission. You would not give it access to the send permission, so to speak.
Build a skill that uses the MCP and then blocks one of the some of the tools that the MCP has, for example. But yeah, just the idea of controlling it.
I like that. I think that covers shaping the harness pretty well. I feel I have a good grasp. Maybe let's spend the last few minutes in the episode talking about building a harness altogether.
Sounds good. The idea is that at some point, these generic tools that we're using, right? So like think of Claude or Cursor, they stop being enough for what your company is doing, right? They can only take you so far because especially in the context of larger enterprises, it's like you have a lot of custom stuff going on. So building software becomes something very specific, like very different from in other environments.
I like that a lot. One of the most popular skills, I think, that's out there by Jesse Vincent, super smart guy. It's called Superpowers. And the idea is it's a bunch of skills that, in a nutshell, forces you to follow the software engineering process well. So the skill will automatically prompt you to first brainstorm, come up with the proper execution plan, or what sometimes we call like an ERD, writes the tests. It forces like a TDD kind of practice. It makes sure that you set up work trees, Git work trees. So it's almost a full system that will enable you automatically to do the right thing. That's like, I think, the first level, which is like, hey, wouldn't it be nice if my company just had something like this? Because different enterprises and companies, to your point, probably approach the process of building software differently. So wouldn't it be nice if I could encode that into my agent so that anyone who uses the agent at work will naturally gravitate towards that?
Yeah, and when you stretch in that direction, like if you keep going that direction, what is it that you want? Like you want to trust the agent more. For example, when you have these superpowers things, like, okay, now I trust the agent more because I know that it's going to be doing this and I already tested it. So you start going that direction. So what else can you do? Maybe at the very end of this line is like having like autonomous agents, right? Like doing things without like involvement. And I think this is what, for example, companies like Stripe went for. So they shared this article recently, what they call Stripe Minions. It's a good name. Basically, it's a fork from Goose, which is also a coding agent? What is Goose?
Oh, yeah. It's an open source coding agent, right? This is from the Square or the Block guys. Almost like an open source version of Cloud Code.
So Stripe, like how they justify is that they have this very heterodox tech stack and they have payment security requirements and a lot of internal tooling. So they wanted to be, like to have the confidence in the agent. So then they went all in really customizing how the context is surfaced and how these dev boxes are launched and all these things.
I honestly am also liking the approach where we explore using open code, the client, like that you turned me on. Again, it's open source. So this is the beauty, right? So it's almost like I get Cloud Code, but an open source version of it. What does a world look like where I can take open code and, layer in some of these things? I just think like someone should try to do this. Like what if you built a custom version of open code with superpowers, built in, just something like that. I can see that being a really good natural evolution of the next step.
Yeah, very, very early days, very interesting.
I will say like the only issue with this is the more you go in the direction of trying to create something custom, the onus of maintaining that is also on you. The burden of maintaining that is also on you. So that's one thing to be careful. That's why most big companies are able to do it because they can dedicate a team. But, I wouldn't suggest the single developer out there go about, building your own harness. Or maybe you should. I don't know. Maybe some people can.
Yeah, watch out to not to try to re-implement Kubernetes.
Deep cut there.
Or,
Okay, Iury, I like that. We talked about shaping the harness and building the harness. Maybe it's time to close this episode. Are there any parting thoughts you have?
If you zoom out, we've gone from prompt engineering back in the day, right?
So long ago.
And then context engineering. And now we're at harness engineering. And it's kind of interesting that how each one will point to a different leverage point, right? From how to use the prompts to when to surface the context and how to manage the context, and finally to the harness, which is the environment of the agent itself.
Makes sense. I like it. Prompt engineering to context engineering to harness engineering.
I hope we stop at some point.
I know. All right. Thank you all for listening, and we will catch you in the next episode.
Catch you guys in the next one.